Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this Security Boulevard Roundtable. My name is Cody, and welcome back to Techstrong Learning. We have an exciting panel ahead, but before we get this conversation rolling, I do have a couple of housekeeping notes I'd like to review with you. First of all, we are recording today's session. So if you'd like to rewatch, if you'd like to share with your team, you will be receiving an email with a link to access the recording on demand, and you'll be receiving that shortly after we conclude this live session today. If you'd like to engage with us, there are a couple of options for you to do so. The first option is the chat tab. You see that chat tab on the right side of your screen. I'd like you to let us know from where in the world you are joining us. Now, if you have any specific questions, we do want you to direct your questions to the Q&A tab, which can be found directly to the right of the chat section. Additionally, if you look over at the handout section, you'll see that there are a couple of resources there for you to download. And as a follow-up, we will be sending you the CISO summary of Aqua's 2023 Cloud Native Threat Report. We'll be sending that to you after the webinar today. And before we close things out, we are going to be giving away 4 $25 Amazon gift cards. So be sure to stick around to see if you're one of our lucky winners. So the topic of our roundtable today is cloud security. And I'm joined today by Svi Koren, Field CTO at Aqua Security, and Mike Bazard, Chief Content Officer here at Techstrong Group. So Svi and Mike, thank you both so much for joining us today on the program. Mike, would you like to go ahead and get this conversation rolling?
Great, thanks, Cody. Hey guys, welcome everybody. I'm going to get started with a fairly simple question, but it probably has a long answer, but we'll see where we go from here. But Svi, we've been at this cloud thing now for a little more than a decade, and I think security has been an issue since the 2 minutes after the first cloud service was turned on. So we've been at this for a while, and yet it feels like we're not making as much progress as we might, or should be, at least we might have anticipated, because we're still having a lot of the same problems and issues. And is this just a question of maturity, or is there something else fundamentally afoot here? But from your perspective, what has made cloud security so challenging and continues to make it challenging?
Yeah, absolutely. But first, hi, Mike, Cody, thanks for having me again. Yeah, so the question of why cloud security is so complicated, or why it is perceived to be complicated, is something that we've been living with for probably going on 15, maybe even more years now. I think the question can be divided into two. One is, there is really difference between doing security in a public cloud environment versus security in a traditional old school data center where all the assets are actually in our physical realm, in the sometimes in the building, sometimes in the basement of the building, and there are differences there. One is the fact that we really don't see the hardware, right? This is all going over the wire. And it's kind of hard, I think, for security people, specifically old school security people, to kind of conceptualize, what security is, where you really can't see the components. So one of it is perception. But the other one, which I think is even more of an issue here, is speed and scale. Because when we had assets internally, when we had assets that we need to procure, that when we needed to account for every piece of hardware, for every operating system that we had in our data center, it slowed things down. When somebody wanted to build a new application, they would have to procure the hardware, found a place for it in the data center. There'd be a lot more people involved. So security was comfortable in a slow-moving process, and there was always time to do the security at some point. Now, with cloud, the fact that things are provisioned on demand, where almost anybody, whether sanctioned or not, right, we have this problem of shadow ID, can quickly provision a service and do it at scale and do it replicated. This is really what is causing a lot of the angst around security. It's not that we don't know how to secure assets or even how to secure assets in the cloud. It's just that the rate of change, the rate of complexity, the rate that even the cloud providers are changing their own services and add services or change the way that they're configured is all causing this rat race around trying to figure out what is the best configuration, the most secure configuration for the services that we're going to consume. Can we enforce that configuration in the cloud? Can we do it in a timely manner? Can we do it in scale? And those are the things that are still difficult, and we really haven't solved that, I think, as a practice right now.
All right. And as part of that, we've been kicking around this shared responsibility notion for a while, and it seems to be ultimately that the cloud provider is only responsible for securing its infrastructure, and then there's a natural assumption that you would be responsible for the applications. But in the middle of that, there seems to be this lack of understanding or appreciation that the shared responsibility side of that equation for the customer includes the configurations and whether ports are left open. And that seems to be where a lot of the mistakes are made, because to your earlier point, the developers aren't necessarily skilled in those things, and they're going to make a lot of mistakes. So do we need to rethink our adult supervision around this whole process?
Yeah, I think the shared responsibility model, which was, I think, initially coined by Amazon, I think as such, is not helping. And it starts with really understanding, even on the same asset. Let's say we build a VM in the cloud, right? So as a simplest user, somebody who's maybe not totally knowledgeable or just wants to consume a service, maybe as part of the shadow IT, where we're doing something that is still not totally sanctioned by the organization, we're just going to provision a VM. So you go to the console and you say, okay, I want a Linux VM, and you're presented with a menu of options. Some of them are community driven, some of them are driven by the cloud provider. You settle on a distribution, on an image, and then go through a quick wizard with a lot of defaults that leave things as open as possible for the most part, because people want to do something with that asset. And then that gets provisioned. Now, even in that process, you inherit a few things from the cloud provider. You inherit a lot of times the base operating system. But as soon as that gets instantiated from an image to a VM, suddenly the content of that VM, the inside of that VM, now becomes your responsibility as the consumer of that cloud in infrastructure. So it's not just that we have a very rigid shared responsibility model, but things actually shift from the cloud provider's responsibility to the consumer's responsibility. Once you've gone through the wizard and provisioned something, even if you accept a lot of the default of the cloud provider, you now own those, and you now own the maintenance of those, and you're now required to, patch your operating system, or if the properties of the cloud asset change, there's more ways to do things. Maybe now we've gone from one type of networking to another. The consumer of that, the operator of the cloud environment, is required to keep up with that. So the shared responsibility model, I think, is a good start, in the sense that it really tells, and I think it started more or less as a way to encourage consumption of the cloud, because the cloud provider said, look, this entire data center security, having things in a cage, having the physical access control to the data center, we're going to take care of all that. So you don't need to have all these things. And I think from that perspective, from access to the physical data center, I think that's been successful. However, when we move into, okay, now that we've provisioned something and now we have to maintain it long term, there seems to be a shift that not everybody is aware of, that now it shifts from the initial responsibility of the cloud provider to provide some of those defaults and initial states, and then what happens long term over time. And that's where drift starts to happen. And the notion of drift is something that we're seeing a lot in cloud security, in cloud native security. It's the sense that the cloud is very prone to drift. When you set up something in the cloud, it's going to retain its initial state for about 5 seconds, and then things are going to start to change. And tracking those changes over a large number of assets, where the shared responsibility starts it in one state, and then you move to another state, and the shared responsibility model breaks down, is something that I think everybody who operates in a cloud environment needs to understand. And I think the assumption needs to be that as the owner of the cloud account, it is up to us, the users of the cloud infrastructure, to actually take more and more responsibility. It's okay if we take responsibility for things that are the purview of the cloud provider. We can always ask questions. We can always, do something that secures even further than what the cloud provider has provided. But I think the initial way to think about it, if you're going to go in a cloud environment, is that really you need to own security, because at the end of the day, it's your data and it's your reputation, and the way that security is built has to be part of the way that we roll application.
Right. If you make any assumptions anywhere, something bad is likely to happen no matter what it is. But you talked about the speed at which we're operating in the cloud, and that kind of brings me to the next logical question, which is, so we do see that we are deploying applications faster than ever, and it tends to vary by organization, but are we also kind of having maybe a Ralph Nader moment here where we're unsafe at any speed because we are moving too fast, and do we need to slow down? Or is there a way to kind of inject security into a workflow without slowing down the pace of development?
So my personal view is that security doesn't fundamentally change because you're going to the cloud. The mechanics are going to be different. The ability to roll things faster, the ability to roll things at scale, the ability to not rely on hardware procurement like we talked about earlier is going to make things a lot easier. But at the end of the day, any service that we provision, whether internally or in the cloud, needs to have at least its security parameters known, and knowing what the risk is. So an application that is being well designed, as in we know what the different components of the applications are, we know what the security parameters of those applications are, we have the ability to enforce good coding practices, at time of inception, all the way to rollout and then maintenance. Those stages really should be the same whether you're deploying application in the cloud or you're deploying it on-prem. What cloud does is that it reveals the weaknesses, I think, a lot faster and in a lot more destructive way if something goes wrong, because everything is connected. And we saw that if there is an opening in a cloud environment, a misconfiguration, whatever happened to Capital One a few years ago, where just a really silly misconfiguration around access from a cloud management agent to the rest of the environment caused a cascading effect. Those are really things that could really only happen in a cloud environment, because everything is connected, everything is provisioned, everything is driven by web services, and software basically handles all of these. So good security practices really should happen regardless. Bad security practices or inadequate security practices are going to be revealed a lot faster and probably in a lot more destructive way once you move things to a public cloud infrastructure.
All right. You're the field CTO, so that means you're out in the field, and we talked about a couple of misconceptions that people have, but what else do you see that people overlook when they're thinking about cloud security? Or, and I'm sure we don't want to name any folks, but, are there things or patterns that you've seen that other folks can learn from?
I think the one mistake that I'm seeing a lot of is when you start off with a cloud infrastructure, you really want to test functionality. You really want things to work. So an organization that is, I don't know if an organization is just now exploring a move to the cloud, but an organization that wants to substantially move applications to the cloud or start a net new application in the cloud, the initial thought is, can we make it work, right? Do we have the right software and scale? And you start off with just wanting to make the application work. The problem is that when you do that, you really start with an insecure configuration. And that actually happens a lot, right? Even if you write your own program, right? Even if you do anything, even outside of IT, you first want to test functionality. So what happens is that you design an application in a test cloud environment, in an open environment. Everything seems to work. Because all the ports are open and everything has access, and all the users are super users and everything, and then everything works. And now you say, okay, now I want to move that into a production state. Security comes along and says, no, you can't keep all of these open. And then we have this tension between the application side, which wants the application to work, and because we haven't designed our application with all the security parameters already in place, we're afraid to tighten the security around it, because if we start to enumerate every port that needs to be open instead of having everything open, that means that maybe we forget something, and then the application is not going to work, and it's going to be an outage, and going to reflect poorly on the people that designed the application. So that's the trap. That's a trap that I'm seeing over and over and over again, where when you start to develop an application, you do it in a very open environment because you just want stuff to work. And then when it comes to the security, there's always this tension, and you never finish the job of security because organizations are resistant, especially if you already put that application into production or did a pilot with it. The remedy for that is, of course, to get security involved much, much earlier, where we start to define all the parameters around user access rights, network access rights, the division of responsibilities between the different application components. If you're going into cloud native and develop in microservices, either containerizations or functions or containers as a service, that work needs to be done even within the namespace. That work needs to be done in order to define what are the appropriate interactions between all these software components. So not starting the security discussion early enough and hurrying to deploy an application in an insecure way just because we want it to work are causing organizations not to really implement security in the right way, which leaves things open, which can then have this cascading failure effect in the cloud.
Do you think one of the other misconceptions that people have is in their minds, they were running virtual machines on premise and now they're running them in the cloud, and they kind of lifted and shifted a mindset that goes with that? And did they lift and shift a security mindset that goes with that doesn't quite play out as neatly? And I guess, do I need different tools and processes to make cloud security work versus what I might have had in an on-premises world? And people don't necessarily know that till they get there, and then it's too late. They got all this stuff, and it's not quite working the way they thought it was going to work.
Yeah, and if you look at networking, that's kind of the poster child for that, because if you look at most when I used to do firewalling, like back in the early 2000s, we had this concept of kind of crunchy on the outside and soft on the inside, where the parameter of your security was supposed to be very tough and hard to crack, but once you've gone into the internal network, we really didn't have as much segmentation, right? Everything could talk to everything. And because we felt safe, kind of cocooned inside of our on-prem implementation of the network that is protected by our router into the internet, and then all the firewalling and intrusion detections and all the other mechanisms inside of it. When you lift and shift, you kind of bring that assumption with you to the public cloud, where if you take a couple of VMs or 3 VMs or 4 VMs that you might have had as physical, or even on a VMware server somewhere in-house, they were never designed to have this internal segmentation between the application components, because we always felt nice and comfortable and safe inside of our network bubble inside of the organization. But when you move it to the public cloud, even with virtual circuits and all the ability to kind of protect a virtual networking, the cloud itself still needs a lot of open communications. And the upshot of that is that if you take a few application components from legacy servers and put them in a VM in the cloud, you are more likely to actually have overall less security in the network, in the access, right? Once you're inside the networking, administrators had, basically full reign of the machines if they were the trusted bunch. And then once you've gone through the initial exterior of your data center or your networking, everything was soft and in the open. And that's the problem, right? If you lift and shift, you get to a point where you're still leaving a very soft and unprotected core in your applications, but now you no longer have that hardened shell around it, because the cloud doesn't really provide that, right? Almost every machine in the cloud has outgoing network capability, while that wasn't the case, for instance, in our data center. We actually had our firewalls filter traffic out. But now, if there is an intrusion, into a server that was lift and shifted into a cloud environment, and somebody is able to exfiltrate data, I really have not seen many cloud environments that take outgoing traffic as seriously as the internal data center. So now we have a much more disastrous effect in the ability to exfiltrate data from a cloud environment. And that's just one example of how lifting and shifting brings along some assumptions. And as you said earlier, those assumptions may not always be correct.
And a lot of that, to your point, may involve APIs that are kind of different to secure in the first place as well, because that's where the data is being exfiltrated from. So are we not having a broad enough definition of what cloud security really is? Because it does seem to encompass a lot of these different other types of capabilities. And is that something I need to think through as well?
Well, so what we like to think about, at Aqua is that cloud security is just one aspect of your overall application security. So the need to secure your application component, have good coding standards, good selection of components, good internal architecture with segmentation, that needs to happen. Cloud security is everything around it, right? Can we not leave misconfigurations, and as we provision services in the cloud, provision them in such a way that will contribute to security. And then there's, of course, the whole tracking, runtime, intrusion detection and prevention over the running workloads themselves. What I would hate to happen is that because now we're in the cloud, everything becomes cloud security. Cloud security itself is not going to, even really, really good cloud security is not going to compensate for bad application security, and it's not going to compensate for bad handling of runtime events and lack of intrusion detection and prevention. So all these three things need to happen. We need to think of security of the application and its components. We need to think of security of the cloud in the infrastructure to make it as difficult as we can for external forces to take advantage of, but also to protect ourselves from that cascading failure in cloud services. So having a lot more segmentation and then controlling things as workloads are running, because all of that together equals good security posture of an application stack. With cloud security, it's really just one aspect of that.
Mm-hmm. We have one question from the audience already, and I'm going to encourage everybody else to find the chat and Q&A buttons over there. But the question is, one of our attendees is already running EC2, and they prefer installing their own software, so they want to kind of manage the security. But their question is it better to go with a managed service because it's going to be a little more secure because it's provided by somebody who has that level of expertise, we hope? What's your sense of what's the right balance between how much expertise do I need to have versus maybe I lean on external expertise?
Yeah, so in general, I happen to think that managed services are a better way to go when they're appropriate for the application. If they work, you lose a little bit of freedom. So the versions, let's say, of Grafana and the resources given to it will have to be negotiated with the cloud provider, and there's going to have to be some way to keep ahead of those, because the cloud provider will want to upgrade all those. But that's one thing that will happen almost automatically. So if you're going to a managed external service, if it works, if it's the right version with the right resources and it makes sense for the application, I think absolutely we should use it, because for the most part, it's one less thing that you need to worry about. And the bigger problem, as I said earlier, is scale and speed. So a security organization in a typical company is really having a hard time keeping up with all the different components that are in a cloud environment. And if you can outsource the maintenance, the upgrade of some of those components to the cloud provider, shift some of the responsibility for the hardware and core services there, that is usually a good thing. The other side of that is that we now have to contend with things like, is the server provided by the cloud provider, single tenant or multi-tenant. There may be some regulatory or security reasons to choose one or the other. We also have to make sure that they provide the right networking approach to make that a private circuit. I assume that we don't want our Grafana to be accessed externally, and it has to be tied into the application. But if we do all that, then you now have a service that has good security parameters, networking-wise and access-wise, and then it's one less component that you need to manage, and the cloud provider is going to take care of upgrading it and making sure that it's designed in the most secure way, at least as the lower level infrastructure is concerned.
Mm-hmm. We talked about virtual machines, and the idea is that you're lifting and shifting, and those applications tend to be monolithic, and they run on virtual machines, and they feel like on-premise applications. But we're starting to see containers and Kubernetes clusters and serverless frameworks and all kinds of new animals in the proverbial IT zoo that we didn't see before up in the cloud. Is securing those fundamentally different? Is this all getting much more complex as we go along? And will I need different security strategies for each type of thing that I'm employing?
So the answer is, I wouldn't say that you need a different security strategy, because security still needs to handle, storage, networking, access, intrusion, incident response, right? The core tenets of security needs to be upheld regardless of what the workload type is. What's happening with microservices, with containers as a service, with functions, is that we are expected to concentrate more and more on functionality, right? The extreme example is a function, right? A function is really just the application code, and that application code runs in an interpreter that is provided by the cloud provider, instantiated just in time by the cloud provider, and basically it's completely transparent. All the mechanics of making it work are completely transparent because now we have that snippet of code. The other side of that is that we're limited to a few programming languages and a few versions of programming languages, and our function need to be deployed in a very, very certain way. And that's the trade-off. So when redesigning an application and thinking which of the workload types you want to use, a VM, a container as a service function, we really need to think about what our coding practices are, and if they fit, and if they can run on Lambda or Azure Function or Google Functions, that could be a really, really good way to just concentrate on the code, and then all we need to do is basically do a little bit of networking and access controls around it. But for the most part, it's going to work. When you talk about containerization, when you talk about especially Kubernetes, those bring a little bit more managing of security that needs to happen from the consumer of the cloud services. So a cloud provider is going to give you a Kubernetes cluster, let's say EKS or AKS or GKE, and it's going to give you a Kubernetes cluster. Everything inside of that Kubernetes cluster becomes your responsibility. So understanding the security model of Kubernetes, the RBAC model, the networking model, the namespace model, the segregation, all of that, that needs to be knowledge that is retained in-house. And I think security people need to be familiar with it, train themselves or have training on the security model of Kubernetes, and make sure that they understand what the security implications are so they can give good advice to the people that run the applications and manage it in the cloud. So the type of workload itself doesn't really change the fundamentals of security, but you will have different control points on those types of workloads. The mechanics are going to be different, and some workloads are going to have more security choices than others, with VM being probably the most customizable. And as you go towards containers, Kubernetes, and eventually functions, you're going to have less and less choices to make. But then that means that your workload is much more predictable and actually much more secure, because we can actually have less impact of programmers on the fundamentals of how that workload is going to work at the end.
Are there a set of best practices and maybe tools or core platforms that people should have in place for cloud security? I think, we talked a lot about the issues at hand, but fundamentally, what is it that I need to have to succeed?
So if you look at, and the one that I'm familiar with is the way that the Aqua platform works. The Aqua platform has basically the three things that I talked about earlier. It has the ability to look at your pre-deployment application. So that would be the code of the application itself, the components that go to the application, the vulnerabilities that will eventually emerge based on the components that go into the application. It can look at infrastructure as code and anticipate misconfigurations once those infrastructure as code snippets are implemented in the cloud, CloudFormation or any other scripting language. So starting to bring security into the application design phase is absolutely something that organizations should consider. So DevOps security, understanding what the incoming flow of your software supply chain, understanding where components are coming from, and getting all that bulk of security risk actually alleviated in the design phase is going to just create a much more safer working environment. And it also provisions a baseline. And then what we need to deal with as workloads instantiate in the cloud and cloud services get provisioned is that notion of drift that I explained earlier, right? Because if we say that a CloudFormation is going to build us, let's say, a Kubernetes cluster with certain networking profile, with certain permissions inside of the Kubernetes cluster, within a few minutes, things might start to drift. Because applications always need tweaking. We might have not thought of something. And then the question then becomes, do we fix it in place? Do we fix even a misconfiguration in place in the cloud environment? Or do we go back to the development phase, fix whatever scripting infrastructure as code that provisioned it in the first place, and then redeploy? What I described right now, the ability to fix things in code and then redeploy, that is the number one security practice I think that organizations need to adopt. Because as security professionals, our tendency is, we see something open, let's close it. Or we see something misconfigured, or we see a vulnerability, let's patch it. The problem is that with cloud native technologies, specifically things that are either deterministic or do not have persistent storage like containers or functions, it becomes impossible really to patch them in place. So we have to go back to where the developers really started, fix those things, and then redeploy. And that motion of finding a security concern but not fixing it, going to the development side, going to the scripting that did that, and then redeploying it, that cycle needs a software product or software platform that has knowledge of both what's happening in the cloud live and at runtime, and also what are the code repositories that feed that infrastructure. So the type of tools that we're seeing emerge today are the ones that have presence on both sides, and they can coordinate and also drive the process of fixing things through the development process rather than fixing them in place. And we actually see it right now in products today, right? So CSPM, Cloud Security Posture Management, a practice that have been with us for a while, and some of the CSPM tool sets had the ability to then provision a fix right into the cloud, right? So if you see, and that's the example everybody gives, if you see a storage that is not encrypted, the CSPM system itself is going to tell you that it's not encrypted because that's against best practices, but will also encrypt that storage for you, and then seemingly everything should be fine. However, in a cloud native world where everything is driven with software, the problem is that next time there is a deployment of that application and a new storage bucket is provisioned, it's going to be provisioned unencrypted, right? Because we really haven't solved the problem. That storage was provisioned unencrypted for a reason. So if we keep chasing those components in the cloud environment, the way that kind of the old style CSPM used to do, we're not going to get ahead and fix all those misconfigurations. So CSPM solutions of the next generation are going to not only find that there is a misconfiguration in the cloud, but also trace what is the infrastructure as code snippet that created that, identify it, go back, insert a change, with or without human intervention into the code, and then reprovision. And now we guarantee that every future reprovisioning of this service is going to have the right security posture in place. And that is really the process that needs to be embedded in most organizations that adopt cloud, and specifically cloud native.
We've been talking about DevSecOps for a couple of years now, and I guess the question a lot of people get into is, am I going to spend my time retraining the developers to be better security citizens, or do I take my security people and put them more into the application development workflows, but I don't have enough security people to go around? So how do I kind of figure out what the balance is, or how do I approach that?
Yeah, and that's been the case. So, go back to the beginning days of containerization, around 2015, 2016, even 2017. I used to do a lot of meetups and different events locally in different cities, and I had kind of two messages. One was security for developers, and the other one is development for security, because we need to bridge that gap somehow. That gap is always going to be lopsided. There's always going to be way more developers than security people. Another thing that I learned in those early days was that the development organizations usually want to do the right thing. For the most part, the sessions around security in those DevOps early conferences were one of the most well-attended topics. And that's because people really do want to do the right thing. They just sometimes don't have the knowledge for it. So a few things are happening. One is that, we talked earlier about the shared responsibility model and some of the things that the cloud providers can do. Cloud providers are slowly giving us better and better defaults, so that the choice that developers make, that even if you don't specify every security setting, the cloud configuration now gravitates a little bit, not completely secure right now, but they're gravitating a little bit towards security with having better defaults. The other thing is now we have libraries of best practices, and we can do that auditing of code and giving good security advice at inception, right? So Trivi, the open source project that Aqua manages for security scanning, has an implementation free out of the open source project. Just if you look for Trivi on GitHub, it has a plugin for development environment, right? So as you start to even type something, a Docker file or a CloudFormation or something that is going to provision a service in the cloud, it will identify potential weaknesses and encourage you to fix them. And that's one thing that technologically we can do. Another thing we're starting to partner with generative AI to ask questions and receive answers around how to do secure configuration. Part of the problem, as we mentioned before, is that the cloud is fast moving and fast changing. So even if you are a good student of, let's say, AWS's security model, that model changes all the time. There's new services in place, there's new capabilities in place, and keeping up to date is always an issue. However, generative AI, having access to all of that, can give us some answers. So one of the things that you can do, even in the Aqua platform today, is see a misconfiguration in the cloud and then ask a generative AI, okay, what is the best way to fix this? So now, even if the developer or the cloud security architect or the SRE, they're not completely versed in the latest of what you can do in the cloud environment in order to safeguard it, the AI is going to give you pretty good instructions that are going to bring about much secure configuration. So the problem exists. Developers aren't versed in security because they're not totally security people. On the other hand, I think technologically, we can augment and have a little, automated security person on the shoulder of developers, giving them good advice along the way. We can use generative AI to generate some of the responses, because I think the core will to do the right thing is definitely present, and we really need to just encourage it.
We have one question from the audience that pertains to this, but is there a way to measure the return on investment for this kind of work and effort? Because it does take a substantial amount of time and commitment. So how do I position that to the company and say, well, this is worth doing?
So we're measuring actually two things that are very much will answer that. One is the mean time to repair. So if you have a vulnerability in a piece of software, if you have a misconfiguration in the cloud, the sooner you do the repair, specifically on your code side, the sooner you're going to output a software component or a new cloud component that doesn't have that misconfiguration or vulnerability. And we can track that. So you can see if you're, let's say, working with the Aqua platform today, and you're using it for a few months, you can start to get a trend of how long it takes to remediate, let's say, a vulnerability in a container image, because we have those generations of container image, and we can work out how long it takes to remediate those. And we are seeing when those practices are put into use, where we are starting to remediate things early in the process, then we will have, I think, much better outcomes as far as the time that it takes to repair and resolve misconfigurations and vulnerabilities. The other thing that we're tracking is the number of redeployments that happen in the cloud environment, understanding that every redeployment is something that could cause potential problems, right? We want to update the application because we want to get better functionality out of it. But every time we do an upgrade, if there are people that deal with cloud today, you know how stressful that is to do an upgrade system-wide to a cloud service. We want to minimize the amount of times that we do that, and we want to minimize that for security concerns. So how many times are we deploying or redeploying the application or refreshing the application stack because it's a security concern or because it's functionality? It is also a measure of how effective we're doing security in the front end of the process. And these are things that really have, can be tied into actual dollar amount. It could be something that is causing us to upgrade less and have less downtime on an application, or it could be something that is lessening the risk over time because we're getting better and better and faster at fixing misconfigurations and vulnerabilities. And these are absolutely measurable, and we have the ability to display that.
Is there also maybe not enough empathy in the process, as we kind of talk about DevSecOps for a minute? But it seems to me often the security folks go out and find vulnerabilities and they load them up into something, whether it's a document, a spreadsheet, or whatever, throw it over the wall, and developers chase their tail only to discover that the vulnerabilities don't necessarily apply. And then conversely, the developers become inured to the whole issue and they keep making the same mistakes over and over again, and the security people get madder and madder. So is there some way to kind of bring everybody together, and short of maybe locking them all in the room for a week, but how do you kind of get everybody to line up a little bit to improve cloud security? I know we're making progress on certain levels, but is there any silver bullet?
Yeah, so one of the things that I've been preaching for a while now is that security needs to be reasonable and accommodating. It doesn't mean that we're going to give up the controls that we need to have, either for security because it's the right thing to do or for compliance. But the notion that somebody is going to tell any development, let's say in containers, that your container images should not have any high or critical vulnerabilities as a rule, it's just not workable, right? First of all, because new vulnerabilities are discovered all the time, and also because there is such a thing as compensating controls, right? You can run with even a higher critical vulnerability if you understand what that vulnerability is and if you have the compensating controls around that. So security absolutely needs to be more reasonable, and I think empathy is a great term for that, because we need to understand that the number one job of application developers is to develop applications that have a good effect on the bottom line of the business or the goals of the organization. Where we're starting to see that things fall apart is where both organizations are rigid and don't work together in order to solve a problem. And that I think is just a measure of in organizations that are just now starting to use cloud native and find themselves in a situation where security and development need to collaborate. It's not natural because we lost the middle part, right? Again, if we go back to our original discussion around why cloud security is more complicated, is because we had that ops buffer in the middle when everything was on-prem. Now we don't have that ops buffer. I mean, we have DevOps, which is a lot more dev than ops. And ops has been basically subsumed inside of dev, and dev and security really don't have that trust relationship. I think that security and ops was back in the days where everything was done manually. So there is definitely some trust to bridge. There's definitely different goals of the organizations that they can both align around. The good news is that I've seen this. It's really just a matter of working out the mechanics, because there is goodwill actually on both sides. I think security knows that in this day and age, you can't really say no to anything. You just need to understand what the risk is, try to mitigate it as much as you can. And if you can't mitigate the risk, just tell the organization that there is immense risk if you identify it, and then let the organization really figure out if they want to assume the risk. On the other hand, I don't think anybody in a development organization is willfully outputting insecure configuration intentionally, or is intentionally writing their application in a way that is not going to contribute to security. It's usually because of the speed, because of as I said earlier, the testing on an application that leaves everything open, and then the inability or the fear to then start to tighten security. But those can be alleviated by having that conversation up front. So I would say that security organizations, first of all, need to come in with the approach of how can we help, provide that tool set, like I said, even access to AI or a platform that can help in the remediation of security events, and really set up good guidelines as to what is acceptable and not acceptable, understanding that you can't have zero acceptable for security risk, because otherwise nothing is going to happen. And that's going to depend on the organization, right? There are organizations where security is much more of a central tenet of their existence. If you talk about government, military, banking, and so on. I'm not saying that other industries should be lax, but the tolerance for risk is definitely different between different companies, and each organization needs to understand what their tolerance for risk is, make sure that it's communicated, make sure that everybody upholds it, and then we should have good collaboration between security and development if everybody knows what the acceptable level of risk is for the entire organization.
What is your sense of what are the bad guys up to? Are they getting smarter about all this? Are they finding weaknesses in the cloud more aggressively? Clearly, there's more workloads up there than ever, so that presents a rich target. But what's your sense of what they're up to?
So I think it really divides into two parts. One is the kind of low-hanging fruit of intrusions, right? If you leave your Kubernetes cluster with worldwide access to the Kubernetes API, you're going to have Bitcoin miners flooding your Kubernetes cluster within minutes, right? Because those bots are going to be there. They're looking for those openings. They're looking for those misconfigurations, and they will definitely take over your environment. So I think there is a bunch of attackers out there, the ones that are just opportunistic, the ones that are looking to steal resources or to maybe kind of fish around and see what they can find. Those are usually limited to the lowest hanging fruit, to blatant misconfigurations, blatant unfixed vulnerabilities. I'm sure there are, those log4js out there somewhere that will still happily, run an executable just because you give them a malformed packet. So those are there, and those are always going to be there because it's still lucrative, I think, for attackers to go after those blatant misconfiguration. And then we have the more targeted attacks, right? So the advanced precision threat, the state actors, the people that want to have a much more sophisticated intrusion that is really targeting the organization. I would say, and admittedly, I don't have the data to back this up, but I think it just stands to reason that still humans are the weakest point. So they would go after targeted phishing, spear phishing, trying to trick people, trying to get administrative access. It's not going to be by brute forcing a vulnerability and doing some really, really elaborate, memory type manipulation in order to gain access, because humans will probably do it 10 times faster. On the other hand, we have seen it. If you look at some of the research that the Aqua research team has done, our team Nautilus, Crabhead was a very nasty exploit against Redis databases that we discovered a few months ago. We are seeing more and more sophisticated attacks that are using a vulnerability or an opening to go from the Kubernetes cluster or the cloud environment into more and more secure areas. So even having an open Kubernetes cluster might result in a bunch of Bitcoin miners. On the other hand, there is always the ones that will use that while running Bitcoin and try to work their way into the other parts of the cloud environment or even into the internal network in a much more sophisticated way. So we're seeing all of that. We're seeing the complete spectrum, and for the most part, right now, the best way to defend against it is to really close down those blatant misconfigurations and vulnerabilities, unless you're an organization that is specifically targeted. If you're closed enough in a reasonable way, your opportunistic attackers are just going to move on, and the bots are going to move on to a different target. So I think there is, from the bang for the buck, if we close misconfigurations, deal with those blatant vulnerabilities, especially fixed vulnerabilities, we're still seeing that from our data that even Aqua customers right now still run about 80% of the vulnerabilities that are present in running environments right now have fixes. They have just not been implemented. So implementing those fixes, closing out those misconfigurations is going to contribute a lot for the security of the environment, unless you are specifically targeted. And if you are specifically targeted, it's probably going to be based on users and not necessarily trying to hack into your cloud environment.
All right. We mentioned AI briefly, and I'm going to assume the bad guys are using AI these days, but will AI be more helpful to the defenders or the attackers, do you think, going forward? Can AI save us from ourselves?
I honestly think it's pretty much symmetric at this point. Because the state of generative AI today is really about using existing knowledge, from the internet to formulate responses to problems that we really know how to solve. There's aspects of AI that will eventually be tasked with problems that we don't know how to solve. But right now, it's really tasked with just solving the problems that we know how to solve, just doing it a lot faster. So I can definitely see in the future, and it's not too far away, right? Maybe a year and a half, 2 years from now, you will have AI, generative AI, with enough confidence to fix vulnerabilities and misconfigurations automatically. So I think right now, people are not ready to trust an AI to do the entire cycle, but it's going to get better, right? So if we see a misconfiguration in the cloud, identify which source code had that issue. The AI is going to determine the appropriate fix in the code, implement it in the code, and redeploy. So that automated system, and this is really what we want to get to, is an automated system that is continuously self-healing, self-patching, self-remediating with the help of AI. On the attacker side, the AI is going to be, I think, allow the bots to be way more independent than they are today. So the bots today have a set of instructions. If they can see an open Kubernetes cluster or a particular vulnerability, they will try to execute the code. If they can't execute the code, they will move on. I think AI is going to allow those bots to be more independent. So you will have more persistent bots that will maybe try different avenues, that will maybe have a way to get an intrusion pattern that is maybe adjacent to what the intrusion pattern that did not work, and maybe try different things. And you can almost see it as now war of bot against bot, right? You'll have the security bots that keep patching and fixing and doing all these things automatically, and you have the attack bots that keep trying to have more and more and more attack patterns identified. And at some point, we're going to get to an equilibrium today, pretty much as we have it today with humans. So I don't see generative AI as a game changer. It really depends on who's going to do it first. And I think it's easier to do it on the attacker side. They're a lot more motivated. And I think security probably needs to kind of let go of some of its conservative ideas so that we can get to a point where we can have AI actually remediate a risk continuously, so that we can counter some of the advancements that are temporarily being made on the attacker side.
All right, folks. Well, I think you got the summary here. The cloud security, complicated, challenging, can be done, but the response times are narrowing. You got to be faster in your general response. And by the way, it may come down to whether my bot can beat up your bot at the end of the day. All right. Hey, thanks for spending some time with us. I'm going to hand this back to Cody, who's going to take us out.
Perfect. Well, thank you, Mike. And Zvi, thank you so much for joining us here on Techstrong Learning. It's always such an honor to have you here with us.
Thank you.
So I'd like to remind everyone that we have been recording today's session. So you will be receiving an email with a link to access the recording on demand. You can also find it living on the Security Boulevard website. Just visit securityboulevard.com/webinars and be sure to look in the on-demand section. The 4 winners of our $25 Amazon gift card drawing are Sai L, Sam B, Tresa P, and Ramsey B. So congratulations to our 4 winners. I'll be reaching out to you shortly to get these gift cards out to you. But if you don't happen to find an email from me, check your spam folder just in case it happens to be filtered out. So to our audience, thank you so much for joining us. If you look in the chat, there is a link to our post-webinar survey, or if you stick around, you'll also be funneled there. And we would love to hear your thoughts, whether they are about today's conversation or recommendations for upcoming topics. Let us know what your thoughts are there. Either way, we hope to see everyone at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect. Thank you again, Zvi and Mike.
Bye.